Alright, today guys we're going to go over ionic bonds, and we want to make sure that we understand how to do this because we have to know how to write the formula, and we also need to know how to name them. So, notes for your ISN or notebook, ionic bonds. Remember that ionic bonds are going to be where you give or take. Those are the two roles that you can have. For example, we have H, and we know it's in group 1, which means it has one valence electron. And then we have fluorine, it's in group 17, which means it has 7 valence electrons. So we're going to put our 7, 1, 2, 3, 4, 5, 6, 7. And remember that the rule is octet. Octet rule means that 8 makes them full and happy. Well, right now we have 7, so we're missing 1 to make it full and happy. This guy actually has 1, so he is going to give it to fluorine. And when he does, now fluorine is full and happy, and he doesn't have this 1 extra electron floating around messing it up. When that happens though, it makes ions. Ions are charged particles. So this guy, he gave up an electron. You're giving up the negative. If you give up a negative attitude, you become positive. So he's going to have a +1 charge. Now fluorine took in the electron, so it's going to have a 1, but he took in the negative. If you stay negative and you take in more negative, you're going to be negative. So this is a give or take relationship. The thing is though, because this is a +1 and this is a -1, opposites attract. So they're still going to attract to one another. They're still going to try to stay by each other because they complete each other. Now when it comes to ionic bonds, we have what we call the crisscross method. And in the crisscross method, what happens is you have element X and element Y. Element X is going to have a +2 charge, and element Y is going to have a -3 charge. Okay, these are made up. These are not real. I just want y'all to understand what the crisscross method is. Sorry, my pen's running out of ink. So what's going to happen is they're going to crisscross. The 2 is going to come down here, and the 3 is going to come over here. Now the plus and the minuses do not matter, okay? So all that drops is that number. So then the X, this 3 drop down here, so it's X to the 3, and then Y, this +2, is going to drop down here, so it's Y to the 2. So by the time you get your chemical formula, it's X3, Y2. Now this is a very broad example, just because these aren't real elements, but I just want you to see what it looks like, okay? Now, that's called the crisscross method. One other thing that you need to know is that with ionic bonds, you have something called binary. The prefix bi means 2. So this is when you're dealing with 2 elements. And then you're going to have polyatomic ions. Poly means many, so it's many elements. Mostly when you have polyatomic ions, I don't know if y'all remember from the notes that we did, when you have a polyatomic ion, most of the time you're going to have ionic and covalent. Okay, so for polyatomic, most of the time you have both ionic and covalent. Okay, so crisscross method. Before we can do practice for the crisscross method, I need y'all to know what the polyatomic ions are. I'm going to post this in Google Classroom for y'all, but this is the polyatomic ion chart. These are the guys that we're looking at. They cannot be separated. That's why they're in parentheses. They can't be separated. These guys belong together. This makes them what they are, okay? So you can't separate the Cl and the O. But if you look, it's got parentheses, and that negative means it's a -1 charge. On cyanide, -1 charge. Dichromate, it's a -2 charge. If you come down here for PO4, it's got a -3. sulfate, -2. Okay, so this is important. I'm going to go ahead and I am going to put it on Google Classroom. If you have a printer, go ahead and print it and put it in your notebook. If you don't have a printer, I would copy these, or I would make sure I know where it is so I can use it when I'm doing my work. Okay, so we're going to go ahead and we're going to look at this crisscross. So you have Na plus and Cl minus. So when you do the crisscross, you have Na plus Cl minus. Remember, there's no number there, so we assume that it's a number 1. Okay? So we crisscross, pull that, and that means we have Na. You could put a 1, but it's understood that it's a 1 because there's nothing there. And then you could pull over this one, and it's a 1. So we have NaCl. You don't have to write a 1 here. So normally when we did the crisscross, we saw it would be Na1Cl1. That's kind of awkward and repetitive, so we just leave the 1s blank, okay? We do not write the 1s, but this is what it looks like. So let's go on to the next one. Now these two, CO3, let's see, CO3 is carbonate. Notice that it's together, it can't be separated. So this guy is going to have to be in parentheses, just to let you know, can't be separated. So when you do this, it's going to be Na plus 1, and then parentheses CO3, and that's going to be minus 2. So what you're going to do is you're going to do your crisscross. So this 1 comes over here. Remember, if it's a 1, we don't have to write anything, but then this 2 drops over here. So it's Na2 parentheses CO3. So that is the crisscross method. This one right here is a polyatomic ion, this one's a polyatomic ion, this one and this one. So all of these remaining ones across the top are going to be on here, and you're going to have to know how to do them. So do what we did on this one right here.